Welcome to Math Life Balance, and today my guest is my colleague with a very beautiful French name, Cancan Gazda.
Perfect.
And we will hear about the moment when Cancan became a mathematician. Stay tuned.
Indeed, I have a fun story to tell. So I was not good at math when I was young. Actually, I was not struggling, but I was not good. I hope that changed for now. My first moment as a mathematician was a very precise moment in time. I was just before the baccalaureate in French, the counterpart of the Abitur in Germany and stuff. And I was sitting in the class, and I think the calculatrice was on the table, and I was just wanting the word to disappear, so I was doing division by zero and stuff like this, just to pop up syntax error. And then we just had a course that I was not following that much before, about a logarithm, and I remembered precisely the teacher saying that you cannot take the logarithm of a negative number. The logarithm of only of a positive number is defined. And so I said, oh wow, yes, I should type logarithm of -1 in my computer. I was expected something like a syntax error, but no, the screen prompted I times pi. So I was just, okay, maybe I broke the thing. I have to rethink about something else to pop up syntax error. Anyway, so for some reason this thing got stuck in my head. I was even not thinking about it, and then I realized that there is a law by Euler of the cosine and sine that was mentioning that exponential of I theta is cos theta plus I sine theta. And so if I plug theta to be pi in this formula, the sign disappears and just remains exponential I pi equals to 1. -1, sorry. So when you take the logarithm on both sides, you will just realize that I pi is log of -1. So I was very happy with this proof, and my life goes on, and maybe a few days later, I realized that the same arguments could work with 3 times pi I instead of just pi I, and why not 5 times pi I and 7 times pi I, etc. I realized that the logarithm of -1 has in fact infinitely many values. So remember that I was not a good student, so I go back to my teacher, and I ask about this fact. What is the logarithm of -1? I can completely understand him now, but at the time I was pissed. He just told me to work something else. I had the baccalaureate coming shortly, so I need to learn something else. That's something that would be useful for me for my exams. I was quite pissed. I think my ego was in my socks. I just wanted to understand what was the answer. What was log of -1, and why does it has infinitely many values? So I googled logarithm of a negative number, and I got to this fun Wikipedia page talking to me about Riemann surfaces and stuff like this, and I was not understanding anything. I tried to find like understandable references. I searched for a long time on the internet, and then I found a beautiful text of Leonhard Euler from the 18th century sur la controverse des logarithmes des nombres imaginaires et négatifs entre Monsieur Bernoulli et Leibniz. So I just found the text, and I realized that in fact, so Jean Bernoulli and Leibniz were fighting about this question in 17th century already. I think Bernoulli was arguing for the fact that the logarithm of a negative number is the same as the log of the positive number. And he had good arguments. He was like, okay, if I take the logarithm of -1 and I take the double of it, then it should be log of -1 squared by the law of the logarithm, which means that 2 times log -1 should be log of 1, which is 0. So log of -1 should be 0. And Leibniz was thinking something else that was not so clear, I guess, but he was saying that the logarithm of a negative number has to be imaginary. And both were arguing, and then it's very funny. I mean, at some point, I think Leibniz is making a mistake in the change of variable, computing the integration of the logarithm, trying to compute log of -1 by integrating along 1 and -1 the differential dt over t. Then he made a mistake in this computation, and then Bernoulli was like, oh, Leibniz, inventor of differential calculus, you should know, blah, blah, blah. So they were really fighting. And I was amazed that, first of all, that you can fight and debate about mathematical structure, that it's not something that is decisive solution. I mean, you can really debate about things and definitions. And also, I was surprised that myself, not so good at class, was asking the same question that Bernoulli and Leibniz at the time. So I was quite, how do you say that, flattered. And then Euler is just finding the solution. He's just saying, okay, those are all the values of the logarithm, and I understand very well the controversy. And here is why Bernoulli got some points, but here is that Leibniz got some point. And he's solving everything. He's almost talking about Riemann surfaces in his own language at the time. So everything was super clear, and then automatically Euler becomes my favorite mathematician. And then I went back to my teacher, and I showed him what I wrote and what I understood from the story about logarithms, and then he was like, okay, maybe I'm going to help you after all. And he was the best teacher in the world. And then he really followed me very closely and guided me through that route. Then afterwards, I checked about Euler's work to understand more, because he was always dealing with infinite series and diverging sums, and it led me to zeta function and number theory. And I think that's really that precise moment that made me a mathematician.